Assalamu alaikum and good morning. Today you're going to do the experiment specific heat capacity of liquid, right? So this is the experiment you're going to do, specific heat capacity of liquid, and you can see it's a general thing. This is the calorimeter with stirrer and the thermometer to be placed, and at one end you're going to heat with the help of this particular burner, and you're heating the solid. Okay, I'll just tell you what solid you're going to make use of it, and you will heat that solid and you will drop a few bits of solid into this calorimeter. So this is how you will do, and you will record the temperature um, where this hot solid transfers its heat to the liquid, okay, whatever you're using it. And here you see the experimental part. So this is the hot solid you have, right? So this is the hot solid you have. I think this is how the solid will look, right? So these are the hot solid, you're going to heat it, right? So with the help of this you're going to heat, and you will drop those solid into the calorimeter, right? So here this is the calorimeter. This is the wooden box, and you have a lid, and this is the stirrer provided for you, and this is the calorimeter. So now this is the calorimeter with stirrer to be weighed. First thing is you should weigh this, okay, and this is approximately 45 gram or 42 gram. Note down that reading. Now you pour the liquid into it, okay. So you will be provided with one liquid. You're going to find the specific heat capacity of that particular liquid. You're going to pour above this half, okay. So 3/4, okay, not more than that, because if you drop the solid into it, then it will come out, the liquid will come out. So you take the liquid in such a way, you should take the liquid in such a way that it should be like 3/4 of the liquid, right? So you pour the liquid. Now you place it here in this wooden box and close the lid. Now you're going to find the initial temperature of the liquid. So insert this thermometer, okay. So you have different range of the thermometer. See, whenever you take the thermometer, you take the sensitive thermometer, means to say it should have so many division in between, because when you're going to heat the liquid, if you keep the one division thermometer, then you can say it reads as 96 degree or 97 degree, something like that, that's it. But when you take the sensitive thermometer, you can also say that it reads 96.10 or 15, so 2025, like that you can say. So now we want that kind of thermometer, because you're not going to heat this liquid. Instead, whatever heat transferred to the solid, that is, you're going to drop that solid into the liquid. So there is a uniform distribution of a heat across that liquid, right? So that distribution of heat will not be that much, in the sense as you heat up, right? Instead it will just slightly transfer the heat, and it will fall as such, right? It will fall, it will drop continuously. So you see that you take the sensitive thermometer such that you should make a note that the division where it reaches the maximum temperature and goes on falling of temperature, right? So this is how you will take. So you take the sensitive thermometer. Now this is the thermometer which reads 1 by 5 degrees C. 1 by 5 is nothing but 0.2. So each division is zero point 0.2. So now if it is the normal temperature, room temperature will be around 36, or if it is winter, then it will be 28 something. So here you can just hold the thermometer like this. You should not hold like this way, right? Instead it will show the body temperature. Instead, hold the thermometer in such a manner and see the room temperature first. So now the room temperature is around 34.8. Okay, so 34.8. Why do I say zero point 0.8? Because the readings has been recorded as point 0.2, point 0.2, point 0.4, point 0.6. So it will be like even number, right? So it won't be odd. So it is 34.8. So the room temperature is 34.8. Now you have poured the liquid into the calorimeter. Now you insert the thermometer here, right? So when you insert the thermometer, what will happen? You can measure the initial temperature of the liquid. So room temperature is what? 34.8. What about the liquid temperature? It will not be more than that of the room temperature, since you are not going to boil this, right? So normal, when you compare when you compare the room temperature with the liquid will be slightly cool, right? So it will be below this 34.8. So it will be around 28 or 26, something like that, right? So you can record the initial temperature of the liquid and note down that reading. Now you're going to drop the solid into it. So now this solid gets heats up at a maximum temperature of 100 or 99 degrees C. So when you heat up the solid, you drop the solid with this opening. Okay, with this opening you can drop. So if you drop the solid, what will happen to the liquid? So the liquid temperature will get heats up slightly, right? So you should stir well and take the reading. Once you drop the solid into this liquid, start the stop clock. Okay, so once it has been dropped, start the stop clock. And this stop clock, when it reaches 10 seconds, note down the thermometer reading where it reads. So now you see the initial temperature as I have mentioned. So you should not stop the stop clock. Once it reaches 10, note down the thermometer reading where it reads. Definitely it will be more than that 26.2. It will be 28.2. Like that it goes on increase. For every 10 seconds, note down the thermometer reading. So how many readings you supposed to take? Because you supposed to take in this, since you have the temperature for the first reading as 26, followed by for 10 seconds is 28, and when you go on with it, then it will read 30. It won't go 34, 36, 38, 50, something like that, because the temperature will go down, since you're not going to heat this. Just the uniform distribution has been the heat distribution has been taken place in the liquid. So it will be around 3 or 4 degree in increase, and followed by it drop suddenly. So like this you will get the reading. So once you get the reading, the see the maximum temperature and the time across. Suppose the maximum temperature it reaches is 36. So 36, see the seconds. If it reaches 150 seconds, so 150 double the time, which is 300. So 300 seconds minus 150 seconds, see the temperature difference also, note down that reading. So that is the d theta you have. So note down that correction. Record the final temperature, which is nothing but the temperature of the liquid followed by the correction across it. So like that you can do it. Thank you. After that, pour the liquid, which is of 3/4 liquid. Again you weigh it, which is nothing but m2. And the third part is, once you have taken the reading, all the readings, and again you note down the reading, note down the weight of this particular calorimeter with stirrer with the solid, and let it be m3. So based on m1, m2, m3 and temperature of the liquid, room temperature and final temperature with the correction to be recorded, and substitute in the formula and get the result. Thank you, girls.